So this presentation is on Yang, XML, netconf, and Python. What I'll do is I'll explain these four concepts separately, and I'll tie them all together as we go along throughout the presentation. Okay, so the hope is that I'll give you a 10,000-foot view of how these things work, in the hopes that when you do read literature, when you do watch videos, when you go to conferences and they're talking about these things, you'll have some background of what's happening. And at the end of the presentation, I'll also give a use case summary of how we may be able to use these things. Suppose I'm a customer and my router is dropping packets. Okay, so you as a customer support engineer, you type show interfaces on the router and you see that all the interfaces are dropping packets. Gig 1 is dropping packets, gig 2, gig 3, gig 4, gig 5, gig 6. They're all dropping packets. Me as a customer, I ask you which one of these interfaces is dropping packets the fastest, right? The rate at which the packets are dropping, which one of these interfaces? If I ask you a question like that, how would you solve that problem with today's tools? One such way you can solve this problem is you copy the data from the CLI, you dump it into an Excel spreadsheet, for example, you cut or you format the data as you like, you display it in some manner like this, and from here you can either graph the output, or just from reading the outputs you might know, oh okay, gig 000 is dropping packets the fastest, for example. So in this scenario, the tools that we've used to troubleshoot is the copy paste functionality, a text editor perhaps. We've used a spreadsheet, we've used some formulas if you're going to graph this, and we've copied stuff from and we've used CLI commands. When we were troubleshooting that previous scenario, what we did was we copied the data from the CLI and we dumped it into a notepad or into an Excel file for analysis. So that idea of copying data from the CLI, that's called CLI scraping or screen scraping. And the problem with screen scraping is what we get is unstructured data. Okay, so what unstructured data means is, assume that I'm tracking this value here, total output drops, this value. So I write a script that can split these lines up, look for this row, look for this keyword, and then extract this value. So if I write that script today, and tomorrow, for example, if this element moves somewhere else, for example here, then my script no longer is valid, right? I'll have to rewrite my script. I have to redo my script here. Or for example, if another row is added to this show interface output, then this row might move down one. So again, I'll have to rewrite my scripts. So it's very hard, and also it's very hard writing scripts for unstructured data. So I'll have to take care of all these white spaces. I'll have to come up with some crazy regular expressions to try to extract this data, so on and so forth. So we're trying to move away from CLI scraping. We're trying to move away from this unstructured data, and that's where this Yang and netconf ideas come into play. Okay, let's move on to the Yang data model. So in the previous slide, I mentioned that CLI scraping and having unstructured data, it's difficult to work with and it's inefficient. So now we'll discuss about the Yang data model. But before that, let's see what a model is. So when people say, when you say a model is just a representation of something. It helps describe something. It helps you. It gives you an idea of what that thing is. For example, here we have a model of an atom, but this is not how actually an atom looks like. This is not how an atom works. But having this model helps you understand that final thing. It helps represent it, it helps describe it, it helps visualize it, so on and so forth, right? So for physicists, this model has a lot of information. So similarly, on the router, we also have various models to describe various components. Okay, so to help you understand that, I'll ask you a question. Let's say you're a router and I'm a client. As a client, I ask you, the router, give me information about CPU usage. So what type of information would you give back to me? You will give me back the different process names, the process ID numbers, percentage values, how busy was the CPU in the last 5 minutes, how busy was the CPU in the last 1 minute, how busy is the CPU now, so on and so forth. So this is the information that you'll give back to me. So I can create models based on this idea. So if I go to this GitHub page, this is the 16.6 release of the Cisco iOS XE operating system. And notice that we have all these data models here that describe various components of the box. So if I go down to CPU, and I click on this, so Cisco has created their own Yang data models. So Yang data models, either the IETF can create Yang data models, right? IETF data models, or the vendor itself can create data models. So Cisco has realized that the IETF, they move too slow. They're not creating models fast enough because it's a standards body. There has to be a lot of checks, and it has to be interoperable between all vendors. So they move a bit slower. So Cisco, to move fast, they create their own data models to help engineers. So if we go to CPU, okay, I click on this. So this is a Yang data model for CPU usage on a router. So if you think back to the presentation slides, we wanted information about what was the CPU usage the last 1 minute? What was the percentage of that? What was the CPU usage of the last 5 minutes? What was the percentage of that? What else do we have here? The interrupt CPU usage, average runtime. So what Cisco have done is, okay, there's this idea called CPU usage. Let's build a general data model to describe that. So this is the Yang data model. And the Yang data model is written in the Yang language. Okay, you can see that it's structured in some way. There's some hierarchy. We have groupings. We have this thing called leaves. We have something called a module. So it's a very hierarchical. Okay, and again, this is just a model for CPU usage. There's models for memory. There's models for interfaces. Okay, there's models for IPv6, models for licensing, layer 3 VPN models. So some models are related to operational data. So operational data just means statistics. Like I want interface statistics, I want CPU usage statistics, I want memory statistics. Other models are related to configurations. I can go in and spin up a layer 3 VPN service, for example. For now, let's just stick to operational data and data models related to that. It's a bit easier to understand. Another way to think about this idea of Yang data models is on the iOS or iOS XE, if you type show process CPU, you'll get some output like this. You can try it on the router now if you want. Show process CPU. So if I was to create a Yang data model for CPU usage, what I could do is I could say, oh, okay, we have show process CPU. To create a generalized data model, let's strip away all these values. Let's strip away these percentage values. Let's strip away these runtime values. Let's strip away everything. We'll just get the skeleton of show process CPU. We'll have these elements here, CPU utilization for 5 seconds, 1 minute, 5 minutes, TTY, process name, PID. We'll have these elements, and using the Yang modeling language, we'll structure the data in some hierarchical fashion here. Okay? So the leaves here may represent different elements of this show process CPU command. Okay? We've structured the data in a logical way, and this data represents the CPU usage model, and then we'll call it CPU module, for example. So there might be another module here with a similar structure like this, which represents the memory usage on the box. So what we've seen from that GitHub page is the router. In the netconf and Yang world, the router is called an agent. So we have this router with all these different models: CPU usage model, mem usage model, running config model, interface model, IP model, layer 3 VPN model, so on and so forth. Hundreds of models within the box. So that's one concept. That's the Yang data model concept. Okay, now let's keep that idea in the back of our mind, and let's discuss what XML means. I'm going to read the definition of XML that I found on Wiki. So XML is a markup language. It is a set of tags and or a set of rules for creating tags that can be embedded in digital text to provide additional information about the text in order to facilitate automated processing of it, including editing and formatting for displaying or printing. What does that mean? Suppose I have a wall of text. Okay, let's say I have a page of text. For a machine to read that text has to be marked up in some way. There has to be tags on it to describe the various things in that page. So I'll give you an example. So this is a business card. If I ask you which one of these numbers is the home phone number, which one is the work phone number, which one is the mobile phone number, you won't know, because you won't know. There's nothing specifying which one is which. So we can tag it like this. This one here, we've tagged it with home. This number here, we've tagged it with work. This number here, we've tagged it with email. In the XML world, they take it one step further. They tag a lot more things. So we've tagged that business card here. We've tagged the person's name with this name tag. Phone type is home, phone type is work, phone type is mobile, email, and we end the business card. Okay, so this is another example of XML. So we have a lot of data here which can be read by humans, but there's also these tags here: paragraph, paragraph, citation, citation. So this page can be read by a machine quite easily because the data is tagged. So I can look for something like list item, index item, and I can get this value, for example. So that's the key idea here. We're tagging the information so that it could be read by a machine. So when we're in the world of machine-to-machine communication now. Okay, we have a manager here, we have the agent. The manager asks the agent, give me statistics about gig 0, for example. gigabit, the interface gig 0. In that case, if we have these Yang data models in place, what happens is the server or the agent, it gets a query, right? It says, oh, okay, this guy wants information about interface gig 0. There's an interface model that we have. An instance of that interface model gets created, for example, here, or a copy of that interface model gets created. Information from that interface, like output drops, output discards, input rate, output rate, all that information gets populated to the interface model. Okay, and that all that data gets mapped to an XML format and gets sent over the wire. So to explain that those ideas a bit further, I've got this slide here. Okay, so as a router, I get a query about, give me information about gig 0. Output drops, is the interface up or down, what's the speed, are there any errors on the interface, so on and so forth. As a router, I have this interface model, a very general model. Okay, it's not specific to an interface, it's very general. What happens is information from gig 0, the statistics from gig 0, they populate these parameters. Name, gig 0, type, it's a gigabit interface. Admin status, is it up? Yes. Operational status, up. When was it last changed? What's the MAC address of the interface? Fill it in here. What's the speed? Fill it here. What's the what's the rate at which packets are coming into that interface? Fill it in here. So I've created a very specific instance of that model. Okay, so I copy that model, I fill in that data, the necessary data, and that Yang model gets transformed, gets mapped, gets encoded into an XML format. If you look at this XML format here, notice that the structure is a one-to-one with the Yang model. Okay, I've got interface status as a parent, interface, name, type, admin status. Look at this. Interface state, interface, name, type, admin status, operational status, last change, operational status, last change. So it's following this data structure, but we just change it to XML format because we have a lot of applications, a lot of programs that can pass through this data easily. Like XML it's been around for a long time, so we have engines that can analyze this data easily. So over the wire gets sent this XML data here, populated with the relevant statistics. So this is a particular instance of that interface model. So now I'll just quickly give you a brief overview of what netconf is. So netconf is just a protocol that allows or that gives you the ability to get data from the box, or you can push configurations to the box, you can edit configurations. When you use netconf, you send data to the box in XML format, and netconf expects to receive data from the box in XML format. So netconf leverages TCP/IP, it leverages SSH for security, but all it is just a protocol that gives you the ability to push data and get data from a router or a switch or other networking devices. At this point, I'll just quickly touch on RESTconf and JSON. To be honest, I haven't really looked into RESTconf too much, but it seems like it has the same functionality as netconf, where you can push configs to the box or you can get data from the box. JSON is similar to XML in that we get some structured data back, but obviously it's in a different format. It's in a JSON format. It's more human readable. So if you're using RESTconf, you can get back the data in either XML format, which has this tag structure, or you can get it in JSON format. And even if we do get it in JSON format, the structure mimics the Yang model as we discussed previously. If you're using netconf, at the moment you can only get back data in XML format. Okay, so what do we have now? So this is a general workflow that you could use to troubleshoot routers using netconf, Yang, XML, and Python. The manager, using the netconf protocol, gives an instruction to the router saying get interfaces. So this will give me the statistics of all the interfaces on the router. The router receives this instruction, this netconf instruction. It goes into its model, it creates a copy of the model, then that model is populated with all the different interface values. The model gets mapped into XML format and sent over the wire to the manager. Then once you have this structured data, you can use something like Python to analyze this data and do graphs or do some other funky things. So that's the end of the presentation. I've put some references here. Now let's move on to a use case. Let's now move on to a practical example which will help tie all these concepts together. So what I'm trying to do in this example is to track how many packets are hitting a particular interface and then try to graph it. So the workflow that I'm going to show you now is not a real workflow. You shouldn't be working like this. I'm still trying to iron out the details, but in subsequent videos I'll hope to make this process a little bit more efficient. So what I have set up here is Ubuntu desktop. It's running this software called MG Soft netconf browser. Basically this application can send data to the box or it can retrieve data from the box. First I'll connect to the box via SSH, and the first time I connect to the router, netconf sends a hello to the router, and the router responds back with its capabilities. And the capabilities just mean that the router shows you the models that it has. So these models are the same as the models that we saw on the GitHub page. Next, let's find the interface model. Let's go down to the operational data. We just want statistics. Right click and click get. So we're getting interface statistics on this box. This box only has one interface, so we'll only see information about gigabit 0. So notice that we get back our data in XML format and it's structured that follows the Yang model. So what I'll do is I'll run this command multiple times, the get command, and I'll copy the data into Python, and then I'll run a script on that data. And what I'm showing here on this top window is this is the command that netconf is sending to the router. Notice that it's sending a get command in XML format. So get me interface statuses on the router. Now that we're in Python, we have the first output, second output, third output, and the value that we're tracking is this in unicast packets. So I've written a quick and dirty Python code that can run through this file and graph these values. And this is the graph that we see.